Welcome to Biotechnology World. Now our topic developing algorithms. Understanding the problem. 1. Before developing an algorithm, it's essential to clearly understand the problem domain, including its objectives, constraints, and available resources. 2. Define the problem scope, input data, and expected output to guide the algorithm development processes. Problem decomposition. 1. Break down the problem into smaller, more manageable sub-problems or tasks. 2. Identify the key components or steps required to solve the problem, which can help in designing efficient algorithms. Algorithm design techniques. 1. Greedy algorithms. Make locally optimal choices at each step with the hope of finding a global optimum. Greedy algorithms are often used in optimization problems. 2. Dynamic programming. Solve problems by breaking them down into simpler subproblems and storing the solutions to avoid redundant calculations. 3. Divide and conquer. Divide the problem into smaller subproblems. Conquer each subproblem recursively and combine their solutions to solve the original problem. 4. Randomized algorithms. Introduce randomness in algorithm design to achieve better performance or probabilistic guarantees. Data structure selection. 1. Choose appropriate data structures to represent and manipulate the input data efficiently. 2. Consider factors such as size of the dataset, the complexity of operations, and memory constraints when selecting data structures. Complexity analysis. Analyze the time and space complexity of the algorithm to understand its efficiency and scalability. 2. Use big O notation to describe the upper bound of the algorithm's time or space requirements as a function of input size. Implementation and testing. 1. Translate the algorithm into programming language of choice, ensuring correctness and efficiency in the implementation. 2. Develop test cases to validate the algorithm's functionality and performance under various scenarios, including edge cases and boundary conditions. Optimization and refinement. 1. Identify bottlenecks or areas for improvement in the algorithm's performance through profiling and benchmarking. 2. Apply optimization techniques such as algorithmic optimizations, code refactoring, or parallelization to enhance efficiency and scalability. Documentation and maintenance. 1. Document the algorithm's design, implementation details, and usage instructions to facilitate understanding and future maintenance. 2. Regularly review and update the algorithm to address bugs, accommodate changing requirements, or incorporate new features. Feedback and iteration. 1. Gather feedback from users or stakeholders to identify areas for improvement or additional functionality. 2. Iterate on algorithm design and implementation based on feedback to enhance usability, performance, and robustness. Open source contribution and collaboration. 1. Consider contributing the algorithm to open source communities to foster collaboration, peer review, and adoption. 2. Engage with other developers and researchers to exchange ideas, share knowledge, and collectively improve the algorithm's effectiveness and usability. Thank you.